All right, so now let's evaluate it using the other formula, our increment formula. Okay, so we're going to use this formula right now. All right, so remember the formula is f prime of a equals the limit as x approaches, or excuse me, as h approaches 0, right, of f of a plus h minus f of a all over h, right? So that's our formula. And so this time we don't have any x's in here, so we're going to replace, or actually let's make this f prime at 3, right, which is what we're trying to find. And so it's going to be the limit as h approaches 0 of f of 3 plus h minus f of 3 all over h, okay? And so let's evaluate, and we found these the other day, but or we know f of 3 we found just in the last problem and in the last video, but f of 3 is 9, right? 3 squared is 9, and f of a plus h, what that would be is a plus h squared, right? We just plug a plus h in there for x, and so we square it, and we end up with, and let me replace this a with a 3. So f of 3 plus h would be 3 plus h squared, and so that would be 9 plus 6h plus h squared, right? But then we'll rearrange that and turn it into h squared, h squared plus 6x, or plus 6h plus 9, okay? So this will be the limit as h approaches 0 of, so we'll put this here, h squared plus 6h plus 9, and then minus, and then f of 3 is 9, so we'll put that here, okay? And then all over h. All right, so before we use the table, let's just simplify here so we know that these 9s will cancel each other out, and so we'll end up with the limit as h approaches 0 of h squared plus 6h all over h. All right, and so now I'm going to plug this into my calculator, except I'm just going to replace those h's with x's, and then I'm going to get very, very close to 0, right? And so, so let's see, basically this will be h, and this is f of h, okay? And so basically what that is, and so so I'm going to get super close to 0, h approaches 0 from the left, and so I'll plug in values like negative 0.1, negative 0.01, okay, and so forth, right? We'll see how far we have to go, and then we'll approach from the right on this side, so where we'll have positive 0.1, positive 0.01, 0.001, and so forth. All right, so let's just get this into the calculator, and then we'll start plugging these values. All right, so this should be familiar. We plug in negative 0.1 and we get 5.9. We plug in negative 0.01 and we get 5.99. So we can pretty, or at least see a pattern developing, right? So let's just plug in this last one just to verify, and then we can continue the pattern. And sure enough, we get 5.999, right? So we can see that we're approaching 6 from the left. As we approach 0 from the left, we approach 6 in terms of our output. And so now let's try values on the right of 0. So let's try 0.1 and see what we get. All right, as you may have suspected, if I plug in positive 0.1, I get 6.1. If I plug in 0.01, we'll get 6.01. And if we plug in 0.001, we get 6.001, right? And you can see the pattern there that we're also approaching 6 from the right. And so since we're approaching the same thing on either side, that means that this limit is equal to 6, right? And so we found now algebraically and now using a table that that the slope of the tangent line at 3 is 6, or another way to say that is f primed at 3, or the derivative of f at 3 is equal to 6. Okay? All right. Now you can still do this algebraically, or any other way that we've done limits, right? But since we did algebraic yesterday, just wanted to show you the contrast with the table today.